this is the notes from September 18th, period 2, Friday, for Math 426. So today what we're going to do in class, we're going to correct homework. Page 157, if we have time today, we'll collect number 7 on the board. And 156 we had to do, and we had to do 1 through 4. We corrected up to 2D. We must finish these, correct 2E and F, and 3 and 4, and we'll have that in the lesson today. First of all, we're going to learn and review multiplying binomials. So you have these two binomials, x plus 5 and 3x minus 2. So you're going to use FOIL to multiply binomials. And when you use FOIL, you multiply the outside terms. The first terms, x and 3x, gives you 3x squared. The outside terms, x times negative 2, gives you negative 2x. The inside terms, 5 times 3x, gives you 15x. And the last terms, 5 times negative 2, gives you negative 10. And so, therefore, if you do that, you get 3x squared minus 2x plus 15x minus 10. You collect the like terms, which are negative 2x and 15, which will yield 3x squared plus 13x minus 10. We're going to look at another multiplication of two binomials. You have 5x minus 12y multiplied by 3x minus 2. Again, use FOIL. Multiply the first terms, gives you 5x times 3x gives you 15x squared. 5x times negative 2 gives you negative 10x. Negative 12y times 3x gives you negative 36xy. And negative 12 times negative 12y times negative 2 gives you a positive 24y. Now, collecting like terms. All of these terms are unlike, so this is your final answer. So the final answer is 15x squared minus 10x minus 36xy plus 24y. We have another example of multiplying two binomials. So you have 5x minus 12y times 10x plus 11y. Multiply the first terms together, 5x times 10x gives you 50x squared. Multiply the outside terms together, 5x times 11y gives you 55xy. Multiply the inside terms together, gives you negative 120xy. And multiply finally the last terms together, gives you 132, negative 132y squared, as follows. Collect like terms. You get the only like terms are 55xy minus 120xy. So you get 50x squared minus 65xy minus 132y squared. So 55xy minus 120xy gives you negative 65xy. Multiply the next question, number on page 156 from the homework question. You had 2f, and you had to multiply this one. So first of all, expand this out. So you have 2 under brackets x plus 1/2 y all squared. So write it out in this form. In the longer form, you have it as 2 under x plus y, x plus 1/2 y, times x plus 1/2 y. There you see in brackets you have two binomials. So you multiply those two binomials first, and then multiply later on by the 2. So using FOIL again, you have x times x gives you x squared. X times 1/2 y gives you 1/2 xy. Inside terms, again, x times 1/2 y gives you 1/2 xy. And the last terms multiplied together, half times a half gives you a quarter. Y times y gives you y squared, quarter y squared. So it yields this. Then, before you multiply everything by 2, collect the like terms inside. And you get half xy plus a half xy gives you 1 xy. And then you have the x squared, and still have the quarter y squared. Multiply each of these terms now by 2. Gives you 2x squared plus 2xy plus 1/2 y squared. That's 2 times a quarter y squared. So that's the answer for 2f on page 156. These ones here we'll correct on the board, and we'll do this in class. So we can add this later on in the PowerPoint. Finally, the next one, we had number 4 to do on page 156. We had to determine the algebraic expression that represents the area. And that's the area represented in red. So you know the dimensions of this shape. This length here is x plus 3. The length across the bottom is x plus 3. And this small part that's not meant to be part of this red area is this black box, and it has dimensions of x times x. So you know that the area of the entire box, including the black, is the length times the width. So what we'll do is look at the area of the entire box, including red and black, and then we'll remove the area of the black. So the entire thing is this length times this length, or x plus 3 times x plus 3, which we have up here. And then you're going to have to subtract the area of this black box, x times x. That's what you get, subtract x times x. So then we do the multiplication. We multiply x plus 3 times x plus 3 gives us, using FOIL, x times x gives you x squared. X times 3 gives you 3x. Inside terms, 3 times x gives you 3x. 3 times 3 is 9. And then you're subtracting the area of the black box, which is minus x times x, or minus x squared. Collecting like terms, you have x squared minus x squared, so there's no more x squared left. 3x plus 3x is 6x plus 9. So this expression here represents the area of the red. The next one, determine the algebraic expression that represents the area, again here in red. So first of all, we'll look at the area of the entire rectangle, including that part in black. So again, you use length times width. So the length is 3x plus 2 times x plus 2, and here's the algebraic expression across the top. You have to multiply those together. So again, use FOIL. X times 3x gives you 3x squared. Outside terms, x times 2 gives you 2x. Inside terms, 2 times 3x gives you 6x, and 2 times 2 is 4. Here, collect like terms, you get 3x squared plus 8x plus 4. That's the area of the entire rectangle, including the red and the black areas. Now we have to, it only wants the area of the red, so we have to subtract the area of the triangle, the black triangle. So the area of the triangle is, the area of a triangle is 1/2 the base times the height. So there's the 1/2. Now this is a little bit tricky. We know that the height, we're finding this triangle. So we can find the length of this base right here, where I have the pointer, by taking, we know the entire length is 3x plus 2, and the entire length of this is 3x plus 2. So to find the length of that, we take 3x plus 2 minus x plus 2, which we have down here, 3x plus 2 minus x plus 2. And if we do that, we can find the area of the base, or sorry, the length of the base. And the height now is x plus 2. So now we have 1/2 times the base once we subtract these two binomials times the height, x plus 2. So we have to simplify this. 3x plus 2 minus x plus 2. 3x minus x is 2x. 2 minus 2 is 0. So the length of this base is 2x. And the height we said was x plus 2. So we have to calculate the area of that black triangle. So we have to multiply inside the brackets first using the rule of BEDMAS. So 2 times x gives you 2x squared. Sorry, 2x times x gives you 2x squared. 2x times 2 gives you 4x. Now you multiply each of those terms inside by 1/2. 2x squared times 1/2 gives you x squared. 4x times 1/2 gives you 2x. Now we're not done because we know the area of the entire thing in the red and the black is here, 3x squared plus 8x plus 4. And if we subtract the area of the black triangle, x squared plus 2, then we'll get the area of the red. And here we've done it. The area of the entire thing, including the red and the black, is 3x squared plus 8x plus 4. And we subtract the area of the triangle, x squared plus 2x. 3x squared minus x squared is 2x squared. 8x minus 2x is 6x plus 4. So that's an expression to represent the area in red. Finally, the last question in the homework on page 156, 4C, we had this one. Determine the algebraic expression that represents the area. So again, we can use the formula for the area of a triangle, and you have two triangles here. So if you find the area of one triangle and the area of the other, you sum them up, that's the area of both triangles. You have one triangle here, small triangle here, and a small triangle here. So let's look at the area of triangle 1. And that is this triangle right here. Again, use the formula, 1/2 times the base times the height. Base is 2x plus 1. 2x minus 1 is the height, times 1/2. You have a binomial times a binomial, so you have to multiply through. And it gives you 2x times 2x gives you 4x squared. 2x times 1 gives you 2x. Inside terms, -1 times 2x is -2x. And last terms, -1 times 1 is -1. Multiply each of these terms inside by 1/2. 1/2 times 4x squared is 2x squared. And 1/2 times -1 gives you -1/2. So that's the area of the smaller triangle on the left. Now we're going to find the area of the smaller triangle on the right. Again, it's 1/2 base times height. So 1/2, base is x plus 3, and the height is 2x minus 1. So multiply the binomials together first, before multiplying by the 1/2. X, again using FOIL, x times 2x gives you 2x squared. Outside terms, x times -1 gives you -1x. Inside terms, 3 times 2x gives you 6x. And last terms, 3 times -1 is -3. Multiply each one of these first collect like terms. So the like terms are -x and plus 6x gives you plus 5x. And multiply each of those terms inside by the 1/2 in the front. It gives you x squared plus 5 over 2x minus 3 over 2. Now you have the area of both triangles represented here and here. Add them up to represent the entire area. So you have 2x squared minus 1/2 plus x squared plus 5 over 2x minus 3 over 2. Collect like terms, you get 2x squared plus x squared gives you 3x squared. You got a 5 over 2x here, and you get -1/2 minus 3 over 2 is negative 4 over 2, gives you negative 2. This represents the area of that triangle. Page 157, we had to divide by some binomials. So we'll correct these in class. We'll look at some common factoring problems. So if we looked at factoring 24, we refer to 24 as a product because it's a product of multiplying two other numbers. Those two other numbers that you multiply together are called the factors. So two factors of 24 are 6 and 4. You can break them down into the prime factors, 2 times 2 times 2 times 3. So the prime factors are factors that are multiplied together, and those factors can only remember what prime numbers are. They can be only divided by themselves and 1. That's what a prime number is. So these are prime factors of 24. Because 2 times 2 is 4, times 2 is 8, times 3 is 24. This is a bit of review because we're going to learn to factor binomials. And we'll start with common factoring. So if we want to factor this binomial, again we call it a binomial because it's two terms connected by a plus sign, and they're two unlike terms. So you look for a multiple or a number or a variable that is common to both terms. So you can see 3x squared can be divided evenly by 3, and 15 can be divided evenly by 3. And if we do that, it's going to yield two different factors. You're going to, if you divide x squared by 3x squared by 3, you're going to get x squared. And if you divide 15 by 3, you're going to get 5. So you can't change the original expression. So what you do is you put the x squared plus 5 in brackets and the 3 in the front. You just double check your answer by multiplying 3 times x squared. Gives you 3x squared, and 3 times 5 gives you 15. Factor this one. Look for a multiple that is common to both terms, 4x plus 6. So you can see that you can divide evenly 4x, you can divide it by 2, and 6 you can divide it by 2. So if we do that, divide both terms by 2, it's going to yield two different factors. And if you take 4x divided by 2, it's going to give you 2x. 6 divided by 2 is 3. You put those two terms in brackets, that binomial in brackets, and you put the 2 in the front to represent the 2 that you factored out. So double check again. 2 times 2x gives you 4x, and 2 times 3 gives you 6. Factor this one. So you look at this term and it says this has a 2 in it and there's a 4. So 2 can be divided evenly in both of these, out of both of these terms. And you see this has an x, this is x squared, and this has an x. So you can divide this by x and you can divide this by x. So a common factor to both of these terms is 2x. So 2x can be removed from both of these terms. In other words, divide both of these terms by 2x. It's going to yield 2x squared divided by 2x is x. 4x divided by 2x is 2. So therefore you yield these two factors of this original expression. It's going to give you a monomial and a binomial. 2x times x gives you 2x squared. This is a check. And 2x times 2 gives you 4x. And let's factor this one. And right away you see a 4, you see an 8, and you see a 12. You know that 4 is a common factor to all of these. And this has a variable a, this has a variable a and b, this has a variable b. So there's no common variables in all of these terms, so it looks like you can only factor out the 4. So divide all three terms by 4. So if you divide 4a squared by 4, you're going to get a squared. You're going to get, divide negative 8ab by 4, you're going to get negative 2ab. And you divide 12b by 4, you're going to get 3b. So here's your factors of this original expression. 4 under brackets a squared minus 2ab plus 3b. Double check by multiplying through. 4 times a squared gives you 4a squared. 4 times negative 2ab gives you negative 8ab. And 4 times 3b gives you 12b. We'll factor this following one. So you have a 3, you have a 6, and 12 as coefficients. So looks like you can divide each of these terms by 3. You have an a in this term and a c. You have a b and a c, and you have a c. So it looks like c is in every single one of these terms. So it looks like you can factor out a 3 and a c. So you divide each of these terms. Divide 3ac divided by 3c is going to give you a. 6bc divided by 3c is going to give you 2b. And 12c squared divided by 3c is going to give you 4c. Divide all three terms by 3c. So that's what we said. So 3ac divided by 3c is going to give you a. 6bc divided by 3c is going to give you 2b. And 12c squared divided by 3c is going to give you 4c squared. And there's double check by multiplying through. 3c times a gives you 3ac, part of your original expression. 3c times 2b gives you 6bc, which is this original term in the original expression. And 3c times 4c squared, 3 times 4 is 12. And c times c squared is, oh, there's an error. This should be c to the third. So we factored out a c out of here. So actually, this should be c to the 1. So there's a correction that could be done. So it should be 3c on to a plus 2b plus 4c. Because 3c times 4c gives you 12c squared. So this is an error right there. But just make note of it, and I'll correct it in my notes.